chapter 6, section 5. Last chapter, or last section in this chapter. Alright, so we've spent a lot of chapter 6 talking about factoring. Okay, so the last thing we'll talk about is factoring binomials. Alright, let's go through, look at some of these examples. Alright. The only time you can factor a binomial is if it's in this form right here where it's a perfect squared minus a perfect squared. Okay, and if it has that setup, you can factor into the square root of the first plus the square root of the second and square root of the first minus the square root of the second. Okay, and the reason being is the reason why you can do this, and I'll show you here in example 1. Alright, is I could actually rewrite x squared minus 25 as x squared plus 0x minus 25. And you could turn it into a trinomial. Alright, and then when you factor it out, okay, when you factor it, you know it's got to be x and x. And you need two numbers that multiply to give me a negative 25, so they have opposite signs. They need to add together to give me 0. So it turns out that's going to be a plus 5 and minus 5. Because 5 times negative 5 is negative 25, and 5 minus 5 is the 0. Okay, so that's the thought process behind it, but you don't actually have to write it out. You just have to say, hey, x times x gives me x squared, 5 times negative 5 gives me negative 25, and there's your answer. All right. So go ahead and try your practice 1, see if you got it. If not, that's fine, but go ahead and try it. All right, so here your answer is, it's x, because it's x of the x squared, and the square root of 81 is 9, so I'll have x plus 9, and then x minus 9. All right, and there's your answer. All right, here's some more practice problems, just a little bit more to it. All right, but you see you have 4x squared. Well, 4 is 2 times 2. And you have minus, and you have 1, which is 1 times 1. So that's going to be easy to do. Since 2 times 2 is 4, we have 2x. And then because of the 1, we have plus 1. And then 2x minus 1. Okay, same thing here on B. 25 is perfect square, so is 9. So the square root of 25 is 5, so I have 5a plus square root of 9 is 3. Since we got the b squared, we need to put a b there. And then we'll have 5a minus 3b. All right. For C, we have a fraction, but if you notice the numerator and the denominator are both perfect squares, so we can do exactly the same thing. We'll have y plus, and then the square root of 4 is 2, square root of 9 is 3, so y plus 2/3, and then y minus 2/3. So that's simple if it's in this form right here. All right, pause it and try your practice 2 problems. All right, here you go. Your A is going to end up being 3x plus 1, 3x minus 1, because we have perfect square minus perfect square. For B, we'll have 6 because it's the square root of 36a plus the square root of 49 is 7, so 7b. And we'll have the same thing but with a minus in the middle. And finally for C, it's a fraction, but the top and bottom are both perfect squares. So it ends up giving you P plus 5/6 and P minus 5/6. All right. Now, if you have things that are not just squared, you're fine as long as those exponents are even. All right, because when you square root with exponents, you're actually dividing the exponents by 2. So we'll end up having here 4 divided by 2, so we'll have 2 is 2, so we have x squared, and 6 divided by 2 is 3, so we'll have y to the third. So I have x squared plus y to the third, x squared minus y to the third. So if you have exponents that are not just squared, as long as they're even, you can do the same thing. You'll just divide the exponent by 2. Okay, so try your practice 3. All right, since 4 is your exponent, you can divide it by 2. It becomes p squared. 10 is even. Divided by 2 is 5, so p squared plus q to the 5th. And then p squared minus q to the 5th. There you go. All right, helpful hint. When factoring, always, always, always see if you can take out a GCF, okay, besides 1. Other than the GCF, if you have a sum, if you have a plus of 2 squares, it cannot be factored. Okay? Then always check to see whether any factors can be factored further. Sometimes you'll have to factor again. We'll see that here on A. So A, I've got an even, and then I've got a perfect squared. So the 4 divided by 2 gives me y squared plus 4. And then the 16, I'll have y squared minus 4. Okay, that's awesome, but we can actually do further. The first one doesn't factor anymore because it's a plus. All right, but that second one we can actually factor again because I have a perfect squared and a perfect squared. So that's actually going to factor into, do it again, y plus 2, because 2 is a perfect square, 4 is a perfect square, and then y minus 2. Okay, so if it's, a lot of times if you see that y to the 4th, it'll be tricky and it'll have that number when you take its square root is actually a perfect square again. All right, in B, since there's that plus, I can't do anything else. Okay, it's already factored. Okay, x squared plus 4 is as far as it can go. All right, try your practice ones. All right, for A, we do have a subtraction, and they're both perfect squares. So we turn into z squared plus 9, z squared minus 9. All right, but since that 9 is a perfect square, I can actually go further. I'll leave the first one alone, z squared plus 9, because it's a plus. But the z squared minus 9, since it's a difference of 2 squares, turns into z plus 3, z minus 3. And then you're factored completely. And B, since there's the plus there, it's already factored. Can't, that's as simple as possible. Already simple. Can't do it any further. All right. So on this one, example 5, notice that both 4x to the third and 49x, they both have an x, so I can factor out that x. All right, if I take an x away from the first one, it'll go from 3x's down to 2, so 4x squared. And then if I take the x away from the second one, it gives me minus just the 49. All right, but I'll look at it, hey, that'll actually factor further because 4 and 49 are both perfect, and there's a minus in the middle. So I'll have the x out in front, and then the square root of 4 is 2, so 2x. Square root of 49 is 7, so plus 7. And then turn around and do 2x minus 7. And now we're factored completely. All right, for 6, I could divide a 2 out. I'm going to go ahead and rewrite this one. 6 is 162x to the 4th minus 2. I can actually factor out a 2. 2 will go into 162 81 times. So 81x to the 4th. 2 divided by 2 is 1. Now it's a difference of 2 squares. Square root of 81 is 9. I've got x to the 4th, which when I take the square root is x squared. And I'll have plus 1, and then 9x squared minus 1. There's another perfect square, though, and it's a difference. So I'll leave the 2. I'll leave the plus 9x squared plus 1. All right, but the square root of 9 is 3, so I'll have 3x plus 1, 3x minus 1. So this one got all the way factored out into here. All right, try your practice problems. All right, for 5, if you take the y out, you'll end up having 36y squared minus 25. And then that'll factor out, because it's a difference of two squares, into 6y plus 5, 6y minus 5. And you're factored. For number 6, I could factor out a 5. If I factor a 5 out, 5 will go into 18 16 times. So 16y the fourth minus 1. That's a difference of two squares. Square root of 16 is 4, so 4y to the second, because the 4 square roots down to the second, plus 1, 4y squared minus 1. But since we have 4 and 1, and it's a difference on the last one, that'll factor again. So I rewrite the first two factors, 5 and y squared, 4y squared plus 1. And then the subtraction, the difference one, will factor into 2y plus 1, 2y minus 1. And now we've factored it completely. All right, and so finally, let's look at these. Again, if you have that negative out in front, factor that negative out. So if you factor out a negative 1, it changes both of those signs, and it turns it into 49x squared minus 16. And now we have a difference of two squares. So I have the negative 1. This will factor into 7x plus 4, 7x minus 4. All right, and then for the same thing for practice 7. I factor out the negative 1. That leaves me 9x squared minus 100. And so that'll factor, because it's a difference of two squares, into 3x plus 10, 3x minus 10. And that's it. That's how you factor binomials. Try them out. Try your math lab, and email me if you got questions.